Okay, chapter 2, section 3 is all about interpreting graphs. And so graphs tell us a story, and we have to be able to read that story and understand what it's telling us. There's going to be two parts to the story that really matter. It's going to be that y-axis and that x-axis. And just as a review from last year, y depends on x. So y is your dependent variable and x is independent. Nothing's going to change how time goes. Nothing's going to change the price, right? If it's a set price, like, you can't change that. So you want to be able to understand really what the story's telling you. So watch what's happening along these x and y axes. Now, on this first one, it looks like increasing speed and then continues to increase, but not at the same rate. It slows down. If it had gone like at a steeper slope, that would have meant that it would have gone faster. So this one, you'll notice, if it comes all the way back down, your speed would have stopped, okay? So you need to watch for what it means if it comes all the way back down. On this one, it looks like we increase and then it slowly, it slopes off, so they're not going as fast. But then this line right here means that it would be constant. It's a constant speed. And then they've increased speed again at the end. So I have 3 different scenarios right here. We just need to pick which story goes with which person. So the first one says, Anne falls in the middle of the race. Well, if you fall, you stop. So we see this one that had to come all the way down. Well, that's Anne. Okay. So then Bob starts strong and does not struggle. So could be this one, could be this one. We need to see what the third one says. Third one says, Carl almost falls towards the end and has a constant speed for a little bit. So this right here tells us that this one is Carl because that constant speed means he didn't increase or decrease his speed. Just means he struggled right there. Bob, on the other hand, never almost fell. So we're able to put which story goes with which graph by really understanding what's happening along that y-axis and how it correlates with what's happening along your x-axis. There's 2 words that you guys will hear over and over and over again. These are a continuous graph. It means that they're aligned. It doesn't stop. So we have a continuous graph. Continuous graph. And it looks like a line, right? Doesn't matter how that line goes. It connects. And that's going to happen whenever you're talking about like speed and time or altitude and time. Time is constant, so there's always something happening then. So time would be along the bottom on a lot of graphs. But so your continuous has to do with a line, and then you also have a discrete graph. Now, in a discrete graph, you have parts where there aren't things, so they don't touch. So an example of this one would be like if you buy one song on your favorite place. I don't know where you guys buy song. Anyway, doesn't matter. So if you buy one song, then you have to pay this much money. If you buy 2 songs, you have to pay this much money. If you buy 3 songs, you have to pay this much money. Well, there is nothing in between there because you can't buy half a song. And so because of that, it's broken up and it's like, okay, this is for 1, this is for 2, this is for 3. If we had like price in pounds would be considered a continuous graph because, so the price depends on the pounds. So I can have somewhere in the middle of 1 pound and 2 pounds, and so that's why your price would be like this, because the more it weighs, the more you have to pay, and there's a price for every pound, even if that pound is in between 1 and 2 pounds. So those are considered continuous graphs. If it stops and you're only buying 1 or 2 or 3 or 4, then, and nothing in between, that's considered a discrete graph. And they show different things and you need to read them a little bit different. We're gonna do some more here in a second.